Chemistry. Okay, so we're moving on to putting atoms together with valence electrons. We talked yesterday about how a bonding electron is always on the lookout for another bonding electron. And that's very simple when you have diatomic systems like hydrogen chloride. Like 1, 2, 3, 4, 5, 6, 7. Hydrogen is 1. These are like, oh, how you doing? Boof, right? Okay, now that's not bad. When you start to have more complicated systems, like, I don't know, good luck circling all of the electrons. You can still do it that way if you're super stubborn, but I'm going to be teaching you a 5-step system to build complicated molecules. Now, this strays a little bit at the end into IB territory, but it's too hard to separate the classes right now. So I'm bringing the regulars up to the standards of IB. Whatever. Okay, so whoop, there we go. It's called the 5-step program. It's not the 12-step program. That's a different program. Hello, my name is Jason Sikowski, and I'm addicted to chemistry. Okay, first step is you need a bank of electrons. You must count up all of the electrons that the compound has, and that is how many dots your diagram should have. That way you don't have not enough dots or too many. Now, we are going to be doing ions, so if something is negatively charged, you add, like if it's 2 negative, you add 2 more electrons to your bank total. If it's positive, you subtract. Okay. Now we're going to do an example in a second. Now, there is a central atom in every molecule, most of the time, that all of the other atoms bond to. The central atom usually has the highest bonding capacity. The central atom is almost always the atom that would have the most bonding electrons. And for right now, we're going to say that that's probably like carbon or nitrogen or phosphorus. You may have to draw the atom's Lewis diagram by itself. Like carbon has got 4 dots, 1, 2, 3, 4. So it's got 4 areas to bond, which means it can bond four different directions. Okay. So you need to set things up so that you have a center and then all the other atoms around the peripheral. It'll make more sense when we get to the example. Okay. Then what we're going to do is the third step is we connect all of the atoms together. That's what you do first. So you make a bond pair that connects all of the atoms to the central atom. And then anything left over, you make sure you fulfill the octet rule for the atom. So I'm going to do 2 examples that show this. Okay. This is going to take some practice. All right. So let's say we had NH3. What is the running total of electrons for NH3? Nitrogen's in group 7, hydrogen's in group 1, but there's 3 of them. So I have 10 electrons total. Now, what do you think is the central atom? Well, if I was to draw nitrogen by itself, it's in group, whoops, I did that wrong, my bad. Nitrogen's in group 5, sorry. Hydrogen's in group 1, there's 3 of them. So I have 8 electrons total, sorry. If I was to draw nitrogen by itself, it has 5 valence because it's in group 5, right? Quote unquote group 5, 1, 2, 3, 4, 5. Nitrogen has 3 bonding electrons. Hydrogen only has 1. So you can't make hydrogen a central atom. It doesn't work that way. Hydrogen is always a peripheral because it can't have anything else bonded to it other than it bonded to itself to make H2 or connected to other groups. Okay, so my first step is that's my running total. It's not 10. I screwed that up. It's 8. So I have 8 electrons to work with. 8. Then the second step is set it up so that your central atom is surrounded by peripheral. Now in this case, I could have put the hydrogen up top or I could have put the hydrogen at the bottom. Try to make it symmetrical. Like if you could imagine like cutting it like this, you could fold it on itself. Try to, when you set it up as best you can, to make it symmetrical. Okay, I don't like how that did that, so we're just going to move this over here. Okay, perfect. Get rid of these dots. Here are some ways to set it up that's wrong. Okay, Doesn't work like that. Hydrogen can't bind to more than just itself or one other substance. It's not a central atom. Also, I don't want to see this garbage. This is going to be for the people who just jump right to the assignment. Doesn't work that way. Okay, third step is use bonding electrons, or bond pairs, to connect peripheral to the central. That used up 6 electrons. I have 2 left. Now, hydrogen doesn't get more than 2 electrons. It's a special compound. It doesn't get more than 2 electrons around it. And by around it means, like if I was to draw a circle around hydrogen, it only gets 2. So that works, that works, that works. Nitrogen is part of the octet rule system. It needs 8 electrons around it. So I'm lucky I have 2 electrons left over, and they go on it as a lone pair. So you're putting electrons in to fulfill the octet rule, usually for the central atom. There's some that don't fulfill the octet rule, but nitrogen does. And the reason why it does is this almost goes to the IB kids will get this. Hydrogen has, in the first S shell, possible 2 electrons could fill it up. It's 1s1. And if you think back to the Bohr diagram, you have 2 electrons in the first shell. Well, hydrogen only exists in the first shell, but once you get to nitrogen, you can stick 8 electrons in the second shell. Okay, now here's another one we could do. All right. What about NH4? Positive. Well, normally that would be 5 plus another 4 is 9, but positive means it's lost electrons, so it's got 8 electrons. And when I set this up and put my electrons in, I'm done. That's ammonium. That's the difference between ammonium and ammonia. I've connected my peripheral. I'm good to go. Okay, a little bit tougher one. What about PCl3? Oh my goodness, what would that look like? Well, let's do a running total. Phosphorus, if I count over, phosphorus is in group 5. Chlorine, if I count over, is in group 7. And there's 3 of them, so that's 21. That's a whole schwack of dots. I've got 26 electrons. Now, what probably goes in the middle? What has a greater bonding capacity? Well, you can kind of do the shortcut here. The atom that's usually in the least amount is also the central atom. So I'm going to put phosphorus in the middle. Then I'm going to link it up with bonding electrons or bond pairs. That's 6. I've got 20 electrons left. Oh my goodness, where do they go? Well, the peripherals also have to fulfill the octet, right? If I take this and I look at chlorine, this chlorine only has 2. This chlorine only has 2. This chlorine only has 2. This phosphorus has only 6. So let's see if this works out. If I make the chlorines have 8. 1, 2, 3, 4, 5, 6, and then right there, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's 6, 12, 18. I have 2 electrons left. Where could they go? Does everything fulfill the octet? Let's check. Yes, yes, yes. Uh-oh. Nope, there's only 6 there. Oh, but I have 2 electrons left over. Skadoosh. Okay, so by making sure you count up your valence electrons, you make sure you're not missing any dots. Now, what if you put chlorine in the middle? Well, it would just look goofy. And one more time, why does chlorine not work? Chlorine is in group 7. That's what chlorine looks like by itself. It's only got 1 bonding electron. Phosphorus is in group 5. It has 3 bonding electrons. The larger bonding capacity goes in the middle. Okay, finishing today's lesson. Now, you may run out of electrons before you're able to fulfill the octet. Now, does that mean you just leave it? The answer is no. The answer is no. If you have to fill up a central atom's octet, what you can do is create a double bond. You can actually share a pair of electrons from a nearby atom. Now, that gets a little tricky, but I'll show you what I mean. Okay, let's say I had C2H4, okay? All right, so carbon's in group 4, so there's 8 there, and hydrogen is, no, this is a bad example. Okay, let's try, let's try carbon dioxide. Okay, carbon's in group 4, and oxygen's in group 6, but there's 2 of them, so that's, I've got 16 electrons to work with, right? Okay, so what goes in the middle? Carbon. And let's make this symmetrical, right? Put an O on either side. Okay, first step is link it up. 1, 2, 3, 4. All right, I got 12 electrons left. Next step, put peripherals on. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 and 6 and 12, we're done. Okay, do my peripherals fulfill the octet? Answer is, let's check our oxygen. Answer is yes. Answer is yes. Does this? Uh-oh. No. There's only 4. Do I have any electrons left? Uh-oh. No. So what I have to do is borrow electrons. Those 2 I'm going to share, and those 2 I'm going to share. So what does that look like? Oh my goodness, it's crazy go nuts. Crazy. Okay, that's what that looks like. Now, I'm going to do 3 more. We already did carbon dioxide. Draw that in there. I'm going to do 3 more for practice. And there's going to be an assignment that goes with it, but it's going to stretch for a bit. It's going to be the assignment we're doing next week. So we're kind of going to end this week on this lesson. So it's a little bit longer video today. But okay, so methane, carbon's in group 4, hydrogen's in group 1. So I got 8 electrons. Okay, set it up symmetrically with carbon in the middle. 1, 2, 3, 4, 5, 6, 7, 8. Okay, perfect. All right. Oh, this one, I think that's another problem with that one. So let's do SO3 2 negative. Okay, so sulfur's in group 2, sulfur's in group 6. Oxygen's also in group 6, so there's 3 of them, that's 18. And 2 negative means it's got 2 more electrons than normal. I've got 26 electrons. Now, what goes in the middle? Well, they both have the same bonding capacity, so let's put the atom that is in the least amount in the middle. Okay, we got that. Let's link everything up. 1, 2, 3, 4, 5, 6. I got 20 left. Let's put 6s around the valence in the peripheral. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I got 2 left. Where do they go? Bada bing. Perfect. I don't know I think this one's an error. I think it's an ion, and I forgot to put that down. I don't want to show you guys something that's wrong. Okay. Now, that's just a little taste. We're going to work tomorrow on moving to something called a structural diagram. Structural diagrams are even easier because in a structural diagram, the only thing you show is the bond pair. So if I go back, and you'll love this for the lazy people, if I go back to this one right here, the only thing I show in a structural diagram is what's connecting it. And I show the connecting bond pairs with a line. So the structural diagram looks like this. Oh, glorious. Now you might have seen structural diagrams everywhere, and you're going to learn how to do this on Monday. Okay, that's the lesson for today.